What's up, everybody? I am not a software engineer, but today we're going to take a look at slot machines and how you can program them in Python. So as usual, I have tried to have this be a relatively simple setup. As you can see, we have VS Code right here, and I am in a directory called slots. So what I'm going to start doing is just create a test file real quick, and I'm going to call that test.py. And I just wanted to demonstrate like what kind of functions we might want with a slot machine. So basically, if you think about kind of the old school three reel slot machine you might see back in the day, which is much different than what they have in casinos these days. But basically what that would look like is essentially three wheels or reels, as I will call them, that basically spin a random number of times, and then whatever symbols end up aligning determines whether or not you have won any money. So the one thing that I can kind of think of is the sevens that kind of go across the board, 777. If you get that, then you get a jackpot, right? So we're going to basically make a super easy jackpot scenario, which is when essentially a random 3-digit number gets drawn, and if that happens to be 777, then a jackpot is occurring, or has occurred rather. So what I want to do is basically import random. Which is going to be a little bit different than actually spinning a wheel or, again, a reel. But what I wanted to do is kind of have these reels be, I think what makes sense for this kind of test case is just 0 through 9. So 0, 2, 3, 9. Okay, and then I'll go ahead and copy that and paste it 3 times. So basically, if I wanted a random spin, I can just iterate through each reel in reels, right? And so again, this is a list of lists, essentially. So what I can do is have a function called spin. So I'll call that def spin, and basically have that be a string that starts with nothing in it. We'll call that spin result, and that will be blank, and we'll basically say, for reel and reels, spin result plus equals random.choice reel. And then we can just return that. And this needs to be a string as well. So then we can just go ahead and run that again. And we get our random string, and I can just run this over and over again. And this is basically a very simple slot machine. Now, there's no logic to determine whether or not this is a win. So what we can do at this point is say, let's say for I in range, let's just say 1,000, and then we'll get cur spin equals spin, and then say if cur spin equals 777, print you won the jackpot. Okay, so this is basically going to do 1,000 spins, and each time check to see if that spin is equal to our jackpot, in this case 777, and if so, then we'll print you won the jackpot. Okay, so that's what I wanted to see, is how often can we expect to see a jackpot? So slot machines have this concept of like return to player, right? And that basically means if you put $1 in, like how much can you expect to get back over time? And so in building our slot machines, we kind of need to keep that in mind, right? Because when we're looking up the probability of a jackpot here, the way to figure that out is basically say the number of digits here to the power of whatever total number of reels we have. So in this case, there are 10 digits, and then there are 3 of them, right? 3 reels. So the probability of hitting a 777 in this case is 10 to the 3, or 1 in 1,000. And we can really illustrate this by basically saying, for I in range 1,000, and then I'll just have a counter right here, right? Counter equals 0. And I'll say if current spin equals 777, counter plus equals 1. And then after that for loop completes, then we can just say print there were, well, we'll say an F string, right? There were a total of counter jackpots hit. Okay, so in this case, there were a total of 1 jackpots hit. And so what we can see is there's a bit of volatility here, right? Because we're spinning 1,000 times, the probability is 1,000. But what happens if we added this, or added a 0 here, right? So we would expect to maybe see 10. Because again, the probability is 1 in 1,000. So we're right around the 10 mark. Again, we're starting to see, we do see some anomalies. In this case, we have one that's 50% higher, which is kind of crazy. I mean, that would be, like, if we didn't have this programmed right and we had 15 jackpots hit when we only expected 10 to hit, then we might end up having our slot machine make our casino go broke. And this one, you know, this is super rare, right? So in this case, 10,000 spins, only 5 hit, then maybe our players are like, hey, is this thing rigged? So what we can do is we can just kind of like increase the simulation, right? Because the lifetime, if you think about the lifetime of the slot machine, it could be in a casino for like decades. I mean, if it's an older slot machine or an older casino, a lot of them have probably been in the casino for a very long time, or in play for a very long time. So 100,000 spins, I have no idea how many spins per day the average slot machine gets, right? But 100,000 seems like a decent number. And so there we go. That's under our 1 in 1,000, right? This is actually, the percentage of this is 0.9%, or 0.09% rather. So statistically, this is pretty rare. There were a total of 91 jackpots hit. But what I'm seeing is like this statistical anomaly of being 50% above what my expectation is starting to drop, right? Like the more spins that I have over time, the less likely. So are we going to see 150 jackpots hit out of 100,000? I don't know. But it appears less likely over time. And then again, we can add yet another 0 to this and say, okay, our slot machine's going to have 1 million spins on it. I would bet that that's going to further cement the 1 in 1,000 jackpots odds, right? And so you can see this starts to take a little bit more time to run, but we would expect to see this to closer align to that 1,000 number, 1,000 out of a million being the same as 1 in 1,000, right? And it is. It's much closer. You're seeing much less frequent deviations from that probability, which is kind of interesting. But yeah, so what I'd like to do now is since we have our test, what I'd like to do is kind of increase the functionality so that we can actually, like maybe, what happens if I wanted to deploy a slot machine that had 4 reels? What happens if I wanted to have more than just this jackpot? I mean, this right here is a super boring slot machine, for example. If you only have 1 jackpot every 1,000 spins, your return to player is going to be super low, and again, people are going to stop playing because it's statistically unlikely that they're going to get their money back. So yeah, what we're going to do is try and aim for what you would expect to see on a slot machine in somewhere like Las Vegas, which is typically, it's closer to like a 0.9, between 0.9 and 0.95. So what that means is basically for every $100 you put in a slot machine, assuming your bet size, you know, kind of makes sense for that number, that amount of money, you would expect to get $90 to $95 returned to you. And that would keep you engaged. I mean, you might go over that every once in a while, you might go under that every once in a while, but if I'm playing for a while and I put in $100 and I get $95 back, the odds are, yeah, I'll give it another shot. You know what I mean? And that's basically what these are trying to do with that number returned to player. Okay, so I've created a new file called slotmachine.py, and we're going to create a slot machine class within it. So I've once again imported random, and I have my initialization function here, which is just going to declare reals to, basically, I'm kind of going to cheat here, but just have like an I for I and range 10, and then I'm going to multiply that times our parameter real num. So what that'll allow me to do is when I instantiate this class, then I can input the number of reals that I want to have. And for now, we're just going to have that be the 0 through 9 digits. Again, this is kind of a boring slot machine, but we can expand on that later. And then the other thing that I wanted to do is have my wins, self.wins, set to the win dictionary parameter. Right? So in order to test this, what I can do is I'm just going to have basically create a slot1 equals slot machine, and then we'll just do a 3, and then I guess 777, right? So I want that to be a dictionary, and then I'm going to have the we'll just have the multiplier of a player's bet be the value of that, right? So I'll just have this be, we'll just say it's a 50 times multiplier. You put in $1, you hit 777, and then you get $50 or 50 times your bet. So this is a very simple dictionary here, and what I can do is say print slot1 dot reals, and I can also print slot1 dot wins, and I should be able to get that info. I actually don't need the parentheses here. Cool. So we get the same thing that we had in the test. Now let's change this to like 5, for example. Now, of course, with 5 reals, our jackpot would be 77777, right? And that's going to be incredibly rare because it's going to be 10 to the 5th. So I'm going to go ahead and switch this back to a 3 for now, just so we can have it. And I wanted to calculate a return to player based on this scenario right here. So this is kind of making me think there should be a function within the slot machine called a simulation. And what I'd like to do with that simulation is basically return what the profit would be, what the return to player would be, and I guess the number of jackpots won or winning spins or something. That would be interesting information. So we're going to go ahead and build a simulation within the slot machine. Before we do that, though, we also need to actually be able to spin, right? So, again, going back to test.py, we have this def spin, and I can pretty much just copy and paste that in here. And let's verify that that works real quick. This needs to take self as a parameter. And since we're referencing something in this class that belongs to this instance of the class, this needs to have a self in front of it as well. Cool, so there's our random spin. And I'm going to get rid of these statements for now since I no longer really need them. So basically what we're doing is we're creating a slot machine with 3 reels and the jackpot of 777 with a multiplier of 50 if the user gets that combination of numbers, right? And I'm basically just running this over and over again, and again, we want to have a simulation that will take like a number of spins as well, and will give us the information that we're interested in. So I'm going to call this def simulation. And we're going to take several things as parameters. One is obviously self, and then we're going to do spin count. We're going to do a pot amount and a bet amount. And then basically we're going to declare those all locally, right? And we can do that on one line, basically. We also need several counters. So I'm going to create one called jackpots. Set that to 0. I'm going to set starting pot to pot amount because we're actually going to change pot amount over time. We're going to keep track of how much we've paid out, and we're going to keep track of winning spins. So at this point, we're going to spin the number of spins that we got as a parameter when we execute the simulation function. And I can do that by basically just iterating through that number for I in range self.spin count. And then I'm going to take in a bet amount from the user. So pot amount will basically be incremented by that amount, plus equals bet amount. And then we're going to execute the spin function, right? So cur spin equals spin. And so what we need to do now is basically have a list of hits, right? Anytime we have a spin that matches something that's in our win dictionary, then we should add that to hits, right? So I'm going to do that by saying hits equals, and I'm going to say item for item in self.wins.keys, which as of, in this simulation right here, it's just one, right? But you can imagine as we add reals or we make the game more interesting, our dictionary will be longer than just having this one right here. So yeah, I'm going to have that be all of the keys, right? And then I'm going to say if item is in the current spin. The reason that I'm doing it this way is because there might be a case, if I have 4 reels, for example, and I want to have 777 count for something, but not the maximum jackpot, obviously, then, I basically want to have that be considered a hit, right? And so what I'm going to do then is, you could see a case where if I get a 777 and a 7-7, I only want to pay out the player for the 777, right? Because that's like the maximum payout that they have, and I don't want to give them multiple jackpots or whatever because they got 777 and they got 77 and they got 7, right? I only want to give them the highest paying out hit, right? So the way that I can actually do that is look for the maximum in this newly created hits list, and I can basically say if hits, right, which means if something did hit, then I can have a multiplier, and that's just going to be self.wins and then the max of hits. So we need to determine how much to pay out the player, which will then be we'll just create a variable called payout, and we'll have that be just bet amount times multiplier. And then we'll subtract payout from the pot amount, right? Pot AMT minus equals payout. And then we'll add payout to total paid. So total paid plus equals payout. So we can keep track of that number as well. And then we'll increment our winning spins plus equals 1. And then we want to see if that's considered a jackpot, right? So we should have whatever is in this dictionary that has the highest multiplier, that's considered the jackpot in our case. So we can just have an if statement that's similar to this right here, right? And we can just have if multiplier equals self.wins, and then that max self.wins.keys jackpots plus equals 1. Cool. So I think that pretty much covers it, but we're not printing anything out yet, so the simulation's still kind of boring. So what I'm going to do is after this for loop completes, then I want to calculate the profit, right? So profit is going to be equal to the pot amount minus the starting pot. Right, so there could be a case where we go negative, right? If we paid out too many jackpots, then we went negative. So we want to make sure that that doesn't happen, and that's how we begin like making sure that mathematically our probability is set right, so that we're not losing money by overpaying players. So if our profit is greater than 0, then that's good. We can stay in business. Then we need to basically have. And this is going to be kind of an ugly F string, right? So I'm actually just going to copy and paste it rather than cheat by looking over at my monitor like I've been doing. But yeah, so this thing right here, let's just talk about it for a second. We're taking profit, we're turning that into a float, right? Because it's going to be a decimal value. And then we're also making it human readable in terms of currency, right? So if it's in like the thousands, or every 3 numbers, right, or every 3 digits we'll add a comma. And this will format that with only 2 decimal places. So basically what I'd like to do is then print something out to the user, and we'll have that in the form of a return statement. And so what I'm saying, and again I'm using F strings for this, is I'm saying there are a certain number of winning spins out of the number of spins, right? And then the simulation yielded this amount of profit. And of course, we expect this to be positive in this case, but we need to handle the negative case as well. So I'm going to have that be elif profit is less than 0. And I'm just going to have that basically be identical. However, I'm going to have a negative sign in front of the dollar sign. So the last thing should be else. Cool. So what we can do now is create our slot machine. So I have my slot 1, and then I can print slot 1 dot simulation and then feed it the necessary parameters. So simulation 1000 is the number of spins. The pot amount, we will start with $20,000. We want a nice little bankroll, right? And then our bet amount will set as $2. And again, we have a self that needs to be here. There we go. So there's one win out of 1,000 spins. Our simulated profit is $1,900. So the reason that that happened is because the user bet $2 1,000 times. So they added $2,000 to our starting pot. And so $22,000 minus the jackpot, which is the bet size times the multiplier, right? So that ended up being $100. They basically got $100 back out of their $2,000. So the return to player on this is very low. And the way that we can calculate that is basically just the amount of money that they got back to them divided by the bet amount, right? So in this case, 100 divided by 2,000 is a 0.05 return to player. This is really bad, and once people catch on that it has such a low return to player, no one's going to play this slot machine. So how can we increase the odds that someone actually wins but still maintain profitability in this slot machine? There are several ways, but one of the super easy ones would be to make additional wins count, but maybe for a little bit less, right? Because we could end up adding, like if we started, for example, if I did this. So let's see what happens if I make 777, 888, and 999 pay out a 50x. So you see immediately that my profit goes down. But this still is actually decent. And again, it's because these also have a 1 in 1,000 hit. Now let's make this a 500x. Actually, let's make it 100. Let's make the multiplier 100. So we have a 3 in 1,000 chance of getting 100 times our bet. So that's paying out a little bit better. Let's make this 500 times our bet. Okay, so now our slot machine... Oh, we need to have a return statement here. Whoops. Okay, so now our slot machine is sometimes going negative, and sometimes is just breaking even. So this one right here is probably going to pay out too much money. And so what I'd like to do is start keeping track of return to profit. And I can do that by just adding something here. So we have winning spins out of spin count, then we have simulated profit, and then lastly we should have RTP. And again, that's just going to be the bet AMT times the spin count, right? Bet AMT times spin count divided by total paid. So my calculation for return to player is actually wrong. I need this to be the numerator. So now that we have the return to player calculation figured out, I have added that logic into slotmachine.py, and that is now part of our return statements. What I've done is created a main.py file which imports the slot machine class from slotmachine.py, and I've just copy and pasted in this basically the slot machine that we had there. So what I can do now is rerun that from this main.py file, and it's just a little bit nicer than having it here in slotmachine.py, and I will do that. And so we can just run this multiple times and kind of see that the return to player is all over the place. And part of that is due to the volatility that I mentioned when you only have like 1,000 spins or whatever. Over the lifetime of the slot machine, you would expect, you know, hundreds of thousands of spins, if not millions of spins, right? So we can go ahead and ramp this up to a simulation of, you know, 100,000 spins with an average bet of $2 over time. And then we can start to see that this is actually not profitable. This is a losing slot machine, and thus basically our jackpot table needs to be adjusted. So I could just start by dropping these to maybe 300. And again, the 7, 8, and 9 options are all 1 out of 1,000 odds, so maybe that is going to come into play as well. But just dropping this gets me much closer to my desired return to player of 0.9. Now, what happens if I wanted to make a simulation using a different number of reels? Well, I could basically just copy and paste this, and I could call this slot 2. And just change this to a value of 4. And I've actually come up with a different scenario, right, where I have multiple cases of wins that aren't necessarily, you know, 4 of a kind, so to speak, in this 4 reel slot machine. And I'm just going to go ahead and paste that in, since I've made that look a little bit nicer here. And that actually is just easier to read as well. So what I'm going to do is actually give the player their bet back if they get a 7. The theme of this specific slot machine is going to be 7s, right? You get a 7, you get your bet back. You get 2 7s, you get 7 times that bet. 3, you get 100 times that bet. And 4, that's a jackpot, and you get 1,000 times that bet. So what I'm going to do is go ahead and comment this out since I'm done with my slot 1 simulation, and then do a print slot 2.simulation. And we'll start with 1,000 spins. We'll start with our bankroll of 20,000, and then my average bet size of 2. And we'll go ahead and clear this out, and then rerun our simulation on slot machine number 2. So as we can see, this one looks a little bit low, but we do see some random RTP jumps that are likely due to when a jackpot hits. So again, our jackpot is a 1,000 multiplier. And so you could expect that to kind of throw things out of whack in like a much more volatile or lower number of spins environment. But if we start to increase this to the total, you know, expected lifespan of a slot machine, we can see that this is much closer to the 0.9. If anything, it probably pays a little bit too infrequently, and so we might want to change these numbers around a little bit. Potentially change this to like a 10x, right? Because this is going to happen quite a bit. The 2-7 quote unquote hit that we have, and that does increase this a little bit. Still not quite where we want it. We can get a little bit more precise with the number of spins by adding another 0 into our simulation. And then we obviously take much longer to calculate, but this is still, you know, 0.84, 0.87. Maybe change the 777 to a 150. Let's see what happens there. So that is 0.95, 0.96. So over the lifetime of this slot machine, this might be a little bit too good for the player, but in any case, it is profitable over time, as we can see. So really, that's about as detailed as I wanted to get with this video. It goes to show you like how sensitive to different variable changes a slot machine can be in terms of its profitability. I would like to expand on this topic and start to maybe think about, you know, multiple row hits that can happen in some of these newer slot machines and things like that in the future. And I also think it would be a good use case to get into some graphical programming using a 3D engine or a 2D engine or something like that. So in any case, I hope this was informative and thank you for watching.